Okay, so we are going to go through learning to understand the set notations and sets of numbers. So we will be working out of 5A of the Cambridge Unit 1 and 2 textbook. So this will be incorporated into everything. So in particular, when we move on to writing and function notation, we're going to be dealing a lot with the R. But with real number system, we always start off with n, which is natural counting numbers. So 0, 1, 2, 3. Then we move on to w, and w is whole number. So whole numbers then include 0. So natural counting numbers is a subset of whole numbers. Then whole numbers and natural counting numbers is a subset of integers, z, and integers is negative and positive numbers and 0. Then we go into quotient, which is a fraction, or if we can write it in a fraction. So for instance, 1 over 2, we can write it, and it's a terminating decimal. If it's, we can write it in a fraction if it's a reoccurring pattern. For instance, 1 over 3 is the same as 0.3 reoccurring. Now, then we move into R. So R is looking at some of our irrational numbers. So that is looking at square root 2, e, and pi. Square root 2 has no pattern. Same with pi, it goes on forever, and the same with e. Pi is 3.14, e I think is 2.7 something. And all of these are real numbers. Complex numbers we won't be dealing with unless you are doing specialist math. So to start off with, we need to understand how things are written. So a set is just a collection of objects, a collection of numbers. Um, ele its elements is objects that are in a set. So this symbol here, it refers to elements. So X is elements of A. Um, if I if I've got a line to it, it's saying X elements that are not at A. This is the subset. B is a subset of A, and that's what we said before when we were dealing with real numbers. I said natural counting numbers is a subset of whole numbers. So here, 0, 1, 2 is also part of A. B is a subset of A. Let's look at union and intersections. So intersections mean it must be both, and so and this and that, whereas union is more this or that. So it can be either. So that means if it's intersecting, we're talking about A intersect B, it must be this middle area here because it belongs to both A and it belongs to B. So if I look at the numbers in the intersect, I just got 3 and 9. Likewise, A union B, it could be A or it could be B. So I highlight both those areas. So what are the numbers involved? Well, it's everything inside here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If I had a number on the outside, it would not include that. Okay, so here we are dealing with now a three-way Venn diagram. So I'm just going to get up a highlighter. Okay, so let's have a look at this. First thing I had to do was look at what is similar between X, Y, and Z, and I put those in the middle. Then I had to go what is just similar with X and Y, and what is just similar with X and Z. And I did that for everything. So the question here says find X intersect Y intersect Z. So it must be all of them. If it's all of them, well then it has to be this middle area here. It's the only area that it crosses into all three Venn diagrams. So That means if I'm wanting to find that, draw my brackets, I'm going to have 8, comma 12. Okay, let's erase just this part so I can do the next question. So we don't get confused, I'm going to change color now and I'm going to do it as a green highlighter. Okay, so first thing I'm going to look for is that first part, X union Y. So X union, that union part means this or that. So let's just go, I could have this area here, because this is X, could have this area here, because this is X here, and this is X. So those are the only parts I'm caring about. And then I've got or Y. Okay, so at the moment, I've got everything highlighted except for this. It can't be this part. Okay, then I'm going to change color just so we can compare. So let's look at blue. Now it says must intersect with Z. Out of this area, this here that I'm circling is the only area that we've got that also intersects with Z. So that means, I'll go back to the pen, we are going to have 6, 8, 10, and 12. So when we're dealing with this, just be mindful that it's helpful sometimes to actually draw down a blank Venn diagram and highlight the areas that are overlapping on what you're actually looking for. Okay, let's have a look at this. It says here A, but not B. And this is how we say it with X elements A, X, not the elements of B. So again, if I look at the area that I'm after, straight away it's going to be, where is it? This area right here. Which means if I go straight to my Venn diagram, I can see it's going to be 1, 2, 4, and 8. Now, I want to go over a bit of interval notation now. Now we've gone over sets. So one of the key things that you're going to notice with all of these examples, and I'm happy for you to pause the video and to write them down, but the key part I want you to take out of this is the following. When we have a rounded as bracket, it will not be equal to that amount. So here, because I've got it on the right-hand side, I'm saying it's X is greater than that A. And likewise on this side here, I've got that round. So again, I'm saying X must be less than B. So it's between A and B, but not equal to. The bracket we always must use if we want it to be equal is this squared bracket. So this squared bracket means equal to and greater than, or equal to and less than. So I've got it on this side, and we can see it's equal to and greater than. Whereas on this question here, I've got it on the right-hand side, and I'm saying X is equal to and less than B. So be mindful of that. The other part that we need to look at, and I'll change color so it doesn't get confusing, I'll change to purple. When we have the infinity sign, so I've got the infinity sign here, I've got the infinity sign here, and here. Okay, so one of the things we need to be wary of is that whenever we're dealing with an infinity sign, we don't know the value because it will go on forever. So it will never meet that amount. Therefore, we have to use the rounded bracket because it's never going to meet that point. So let's look at some examples. So when we have done inequalities before, we have graphed them on a number line. So I'm going to do the same here. So if I've got negative infinity to 2, we need to think about what those brackets mean. So I'm just going to draw it. Okay. So if we've got a rounded bracket, it can never equal, but 2 it can. So that means we're really wanting to use a full circle and then an arrow over to the left. Here in B, we're going to have 2 points. We've got -3 and 0. So -3 is not going to equal, so I put a circle, and 0 it will equal, so I color in that circle. And that's going to form a line. So if I do that on a number line, we can see a lot neater than what I've done. Now with infinity, you'll notice that we're just doing an arrow because we'll never get to that point. So for C, it's saying -1. It's not equal, so it'll be a open circle, an arrow to the right. With D, both of them will be open circles because it can't be equal, and it will be on -5 and 1 and a line between. Can you have a go at these 4 questions and then I will go through them. You can pause the video if that helps. So first thing, we're going to have 2 parts here. So I'm going to be looking at both of those. The first part says -4 and 1. So I'm just going to right now, to help me out, I'm just going to draw it. -4 is here, 1 is over here, and I'm going to draw that line over to it. So I've colored them in because it can be equal to it. Likewise, I've got 3 and 7. So again, I'm going to draw a circle and color it in. 7, I'll draw another one and color it in. And then I'll draw a line. Because it says union, which is this or that. So I've got everything here. Let's look at another union, which is B. This or that. So I'll do the first one, starting at 0 and goes down to negative infinity, which means I just keep drawing it. And I've got an arrow going the whole way down. But I can also equal 5. So I draw a dot there. And it'll go all the way up to infinity. Will never meet, so I've got an arrow going to my right. Now this is the part that can get confusing, which is C. It must meet both of them. So what I'm going to do, I'm just going to map out each of those on my number line, and then I'm going to look at what is intersecting. So if I start out, I've got equal to -5 all the way through to 0. Okay, then I'm going to look at 0 and 5 again, so I'll do a dot. Okay, and again, I'm going to draw my line. Okay, so straight away I can see that the only thing that is in common is 1 point, and that is the 0. So I'm just going to do it in purple. I've got 1 point, which will be a dot. I colored in dot on 0. Let's have a look at D. So again, I've got 0, so a negative infinity to 0. So I will do color in 0. Oops, now I did the wrong dot because I was just getting used to it. It says not equal to, so I'm going to change that and do the open dot. Then it's to negative infinity, so I'm just going to do my arrow going all the way down. Then I've got one looking at -8, but it's not equal to it, and goes all the way up. So that extra bit was added based on my lovely keyboard. Unfortunately, I don't have a touch screen right now. So then I look at what is similar. Well, it can't equal to 8. It can't equal to 0, but it can be any number between them. So I will join them together.